Administrative stuff first. The first assignment, I provided a skeleton for it, and there are a few typos that I made. So there's a new version up. I made an announcement on it, but just I would suggest downloading that if you haven't already. It just fixes some of the function prototypes. And then the other thing is John's office hours are now on Canvas. I believe it's 1 to 2 Tuesday, Thursday, and those will be on Discord. So if you haven't already joined the Discord server, I definitely recommend doing that. Anyways, let's get back to where we were. So in the last lecture, at the very end, we started talking a little bit about classes and modifiers. So let's kind of jump back on that. I have here the program that we wrote last time. It's also up on Canvas if you want to do it, or like take a look at it, or attempt to do it on your own. And what I'm going to do here basically is just modify it today so that it uses classes instead of structs, and so that we can get a better idea of where we would use a class and what kinds of things they offer. Right, so first off, let's go over again a little bit about what a class versus a struct was, and then what modifiers were. So a struct versus a class. The only real difference between these two things is the default modifier. So for a struct, remember that this was public by default, or all of its members are public rather by default. And then in a class, all of its members, meaning the variables and the functions that it has, are private by default. And what we said about public and private is public means that anybody can access it, and private means that only the class or struct itself can access it. And just as a reminder from 135, these are called ADTs, which stands for abstract data type. Basically just meaning it's a data type, like an integer or a float or whatever, but it's an abstract one in that the compiler doesn't actually know how to handle it, and we're just using it as an abstraction for things that we can do with our actual programming. So we said that a class is usually the one that you tend to use because it's private by default, and so you can limit a lot of the stuff that you actually end up using and kind of safeguard it from being used improperly. And so here, let's try to modify the code that we have to do this a little bit better. So remember last time that we had like a shopping list example here, where we had a file which I can open that was like a shopping list of items, and so it had the name of all the items, their SKU, their price, and then a quantity. And we basically just read all of these in, sorted them by the quantity, and then wrote them out to a file. And we used a struct to represent each individual line here. So we had a struct called an item that had a SKU, a name, a price, and a quantity, and then we read each of those lines into that. And so what I think we should do for practice is instead make this a class. Now, struct works totally fine for this example, and in practice, a struct wouldn't be a bad choice here, but let's go ahead and do a class instead. One other thing I wanted to go over, somebody brought it up last class, I know, was doing things with multiple files, and so I think we should do that here as well, just for practice, and it's pretty good in practice as well, just to be able to do this. So if I'm doing it in Visual Studio, I'm just going to create a header file. So we have a header file thing here. I think I accidentally done something. I'm just going to click Add and then New Item. If you're doing this just via a text editor on your computer, all you have to do is create a new file called a .h file, and this is basically just going to do that for me. You see here it says header.h. I'm just going to call this item.h, and then it's going to add it in here. I don't need the pragma once. Now, a header file is basically just a file that is designed to contain declarations for your data types. So when you're doing a big project, you're going to tend to have a lot of classes, maybe even like hundreds of classes that you're going to write. And if those were all in one file, that would be really annoying and kind of hard to keep track of. you'll find that it's really common to separate header files based off of classes, or maybe just put a few classes that are related to each other in the same header file. And so what you'll see that I do a lot when we're programming in this class is that I'm going to kind of just move over anything to these class files. So I'm going to take this struct, I'm going to move it over here, and then we said we're going to change it to a class. Now, one thing to note about this is now it can't actually see the code I wrote. So you notice it's giving me like the red line here on all the item stuff because it doesn't know it exists. In order to include a header file, it's probably what you guess, it's just the word include with the preprocessor directive that we're used to, and then it is a string with the name of what you want. So you see Visual Studio is already suggesting it for me. Item.h was the name of the file that we created. And what this literally does is it just goes and takes all of the stuff in that file and then copy and paste it into here. And you'll see that the string error went away too. What this actually does, and it's kind of important to know this when you're doing big projects, is it quite literally, when you do any sort of preprocessor directive, it really just copy and paste stuff into the actual file. So when I do include, it actually goes to all of these libraries, finds all their code, and just copy and paste it into this source file. And so when I put include item.h, all it does is go to the item.h file that I'm writing and just copy and paste all my text into my main. So really, it's almost the same as if I had just written it there normally. The only difference now is that I can kind of separate it so it's easier to read. Right. So I think that's all right. Do we want to move any of these? I think we'll move some of these as well. I think it will help us to move these functions here. So let's move these over. And for the sake of an example, let's put them inside the item class. Now, I don't think they typically go into it in much detail in 135, but aside from variables, you can put functions inside of classes as well and tie them to the class. And I think this is a good idea to use a lot of the time, because you can link actions that you think specifically belong to that class or should operate on that class to that class specifically. So when I have here print item and sort item, then I actually just have these linked to specific items, and I know when I type print item, I mean the item that I'm calling on. I'm going to need to modify these a little bit because I've moved them inside the class, specifically with this item parameter. We're going to go into that here in a second. But for the time being, I'm going to throw that there. I'm also going to have all these be private. I know these things at the top worked pretty well when they were private before, but I'm going to keep those private. I'm just going to make these functions public. Right, so just as a reminder, what this means is that, and all of this stuff here, because it's in a class, private by default, it means that it's not accessible anywhere outside of this class or anything linked to this class, which we'll get into writing that stuff in a little bit here. Which means that now I should be getting an error in main. So remember that we just had read into the SKU and the name and the price and the quantity and did all of that stuff earlier. And now it's giving me an error on that because of the fact that these are private now, right? So you'll see here in Visual Studio it says member item : name is inaccessible. And you'll see that error if you ever try to access something that is private or protected, which we'll get into that in a future lecture, when you don't have actually access to it. So this just means that the modifier that you're using, whether that be private or whatever, is not set up so that you can access it in the scope. We're going to need to fix this in some way. The way I'm going to suggest we do this is we're going to just create individual variables, only one of each, and then we'll do that. So to use a private modifier, would we use a pointer? So pointer is like an address, and we'll get into that in a future class. But for a private modifier, oh, you mean like in order to use it itself, you would use a pointer to the thing. So actually, fair question. That won't work either. If you try to do it with a pointer as well, it'll still just tell you the same thing, unless you do some weird pointer arithmetic, which definitely don't do that. I think that's kind of obtuse way to solve it. Instead, we're going to use what's called an accessor, which we'll get to in a second. But yeah, fair point. But yeah, just consider, we'll get into pointers in maybe next week. Pointers in C++, really the only difference between that and the dot that you're used to, this thing here, is just the notation and what it represents, but is in terms of like usage and what you're allowed to do, it's exactly the same as a normal class object. That is class object. Right, so the way I was going to fix this is just create a variable for each of these, use it as a temporary variable, and then store them in. And you'll see why I'm doing this in a second. It has to do with something else that we're going to cover here. And so I'm going to create an integer for the skew and the quantity. And then I'm going to create a, what's it called, string for the name. And then what was the last thing? It was a float for the price. And what I'm going to do instead is read this into my temporary skew variable, read this into my temporary name variable, and all of that. And then we'll worry about setting all of this stuff later. So what I'm going to need to do here is find a way on this specific line to set the members of the what's it called, item that we're actually creating. And there are a bunch of different ways we could do this. I'm going to go over one general way first, and then I'm going to go over the way that I think makes more sense, that I would normally program it as. And so the first way to do it would be to use what I mentioned earlier, which is a accessor and a mutator. So there's two different things here. They're called accessors and mutators, or more colloquially, just getter and setter, which I think is more to the point, but you know how computer science people have to be. We have to say fancy words. So mutator and accessor is what they're called. And these allow you to get and set the data. We said that the way private variables work is that they're completely safeguarded. Nothing can access them by default. And so by creating these mutators and accessors, we can decide whether it's allowed to see the variable and whether it's allowed to use the variable. So let's take a moment to just think about this a little bit. This button's here. Oh, there. So consider there's really only two things you can ever do with any variable, which is you can use it and you can set it or like overwrite it. The major, operator in any programming language is equals, or assignment, whatever that may be. In C++, it's an equal sign. And so I can use something. If I wanted to, let's just say, talk about some variable called x, then I could see out x plus 3. And in this case, I am using x. It's getting used. And the thing that's getting set here is cout in some way, or whatever the standard output is that cout represents. And so what this does, right, is it just takes whatever's in that variable and then uses it to do math or some sort of computation or a function call or whatever. And the other thing I could do with x is I could set it equal to something. So some kind of expression over here, right? I could have y plus 4 times 7, just throw a bunch of stuff. But the idea is that I can set x and overwrite its value. And so there's these two ideas. One is accessing something. We get the variable, so we'll call that a get. This is where the term getter comes from. And then the other one is set, or mutate is the fancy word, meaning that I just modify whatever value was in x. So the dependency here just applies to where it is with regards to the equal, whether it's on the left or whether it's on the right. And it may not be obvious, just by looking at it all the time, but are we using it or are we setting its value? And so what we want to do is, with these private modifiers, is we can limit whether you're allowed to do both or whether you're allowed to do one or the other. And so public means that you can do both. If your members are public, it means you can do both. If it's private, it means you can do neither. And so what we can do here is kind of do a combination where we make a public way to get it or a public way to set it and then keep the other one private. And so what I usually do is make a function called get whatever it is that you're trying to get and have it return the value. And then if you want it to set, you would do set whatever the thing it is and then provide a value and set the variable. So let's actually take a look at this in the code. I know it's a bit abstract here, but the idea here just being that there's two things we can do. We can get something and we can set something. And we can limit how we do that. So let's just say I want to be able to get and set all of these. Then what I can do is I can write get function for, let's just say, the skew. So consider if I wanted to get the skew is an integer, and the common naming convention is just get and then whatever the variable field is that you want to get. So I'm just going to say get skew, and all this is going to do is return the skew. One other thing you might not have done in CS 135, but that applies to both structs and classes, is that whenever you write code that applies to a class or a struct, you actually don't have to refer to the object except for in certain special cases, which we'll get to. So when I write skew, it actually knows that it means this skew right here. And consider that when I was actually writing this, I have all of those members. So I had a variable called temp earlier. And the way I accessed variables of that specific temp object was with the dot. But when I write code in the class itself, it knows that I'm talking about the variables because I'm writing it in the class itself. And so when I write skew here, there's no dot operator, although it kind of implies it. Anyways, this would be how I get the skew. It's just going to return an integer being the skew. And then if I wanted to set it, usually that's a void, because if you're setting something, it doesn't have a value to it. You're just setting the thing, making it equal to a value. So here we'll just say set skew, and then we would put an integer called new skew maybe, and then we would just set skew equal to new skew. Right, so this allows us to get it and to set it. And if I do it in this way, then there's not really any difference between making it entirely public and private. Although you'll see people still do it this way, and the reason being is it's just maybe more clear to read when you put get and set, rather than putting an equal. It's very clear that you meant to set the thing and you meant to get the thing. You'll see very commonly, though, people will not give you a set option and they'll give you a get option. Let's go ahead and finish writing this just for these things. So I'm going to just quickly type these out. So get quantity, and then this will just return the quantity, and then void set quantity name. Get name. There's no need for prototypes for these functions, correct? These actually are the prototypes. It's just kind of a different way for us to group it, if anything. And that's the way I would say to use header files, is you can put all the prototypes inside the class itself. And you don't actually need prototypes. I take it back. I'm not actually writing them here. These two are still prototypes, I guess. But you can do what's called inline, which is what I'm doing right now, where you just write it right next to where it is, or you can write the prototype itself. I would say inline's totally fine for these ones, because the whole reason we did prototypes in 135 was for formatting reasons, right? So you don't just have a bunch of code before you see main, because main's important to look at. But yeah, it's kind of up to you, but these, you can put prototypes in the class body itself, and then the way you have to define them later is a little strange. I mean, it's basically the same thing, there's just some extra words you have to put in there. We'll say, I'm typing the same thing, aren't I? Get name, and we'll just return name. I'm going to end up deleting most of this, or later, or like half of this later, so probably not great that I'm typing it all out, but new name. Name equals new name. And then the last one was the price, so float get price. And normally I don't do both the gets and the sets. I think that's a little overkill, and I find that in practice, a lot of the times it makes sense to have a get and then not a public set, because you don't want people messing with your stuff. You just want them to be able to get it so that they can use it on their own. But I'm writing them anyways here. So new price, and then we set price equals new price. So what we've effectively done is just limit the way that people using our code are allowed to interact with it. They have to go through this like middleman function in order to get to these things that are guarded because they're private. I'll put private here just for the sake of readability, but just know if you don't put anything, it's going to know it's private in class, and that's what a class is. Now, if I wanted to finish this code that we wrote here, what I would have to do is I'd have to call the set for all the stuff that I read. So I've read, again, like a temporary SKU, quantity, name, price, and so I would need to call that on all of the variables, or all of the items with all the variables. So I need to go to items sub I dot set. Was I using I? I was using count, right? So count dot set name, and then I put the name, and then I do item sub count dot set price, and then I'd set the price, and then etc. Right? So I'd finish doing that. Does this make sense, or does anybody have any questions on why we would set it up this way before I move on to the next part? Okay, I don't see any comments, but feel free to stop me at any point. Right, so I could do this with the rest of the sets, and we'd be able to set the thing. And really, at that point, it's not much different. It's a little bit actually less efficient, but it's more readable from a human perspective. So, this isn't too bad. Another alternative we would have, right, is to just make one function that sets all four of these if we know we're going to be using it in a way where we need to set all four at the same time. And I would argue that's a pretty good way to do it. And so what I'm going to do is let's do that, but let's do it in a bit of a special way. Recall that last time this goes away. Recall that last time we talked about the difference between an instance or an object and a blueprint like a class or a struct. When I write a class, remember that this is just a description of something that can be made. Didn't write that much better. Oh well. So when I write this, I'm saying, well, when you go to create an item, or telling the compiler really, when you go to create an item, it needs to have two integers with these names. It needs to have a float for the price and then a name, right? So, and this is a string name, and so this was a blueprint. Or a recipe. It just tells you how to actually create it, what's it supposed to contain, but it doesn't actually make anything, right? This doesn't create any specific item, it just tells you how an item should be created when you create one. The creation is always done whenever you do a variable declaration. So if I wrote something like item I, then it goes off into space and it says, okay, now this has a name that's equal to probably nothing by default, and it has a price that's equal to something, probably 0 by default, and then it has a quantity and all that stuff, right? And anytime I modify any of these, it's distinct from any other instance that exists. Skew, that didn't turn out well. Skew equal to 0. And so this is my variable I. And I might go and make another one called J, and it's just going to exist, and it's going to have all the same stuff, right? It's going to have a name that equals something and a price that equals something. Right? And anytime I modify one instance, then it's not going to affect the other instance. They're kind of like their own individuals, and nothing really interacts with each other unless we specifically set it up that way. Individuals or instances is probably the word I should use. Whenever we have a variable declaration where we write the type name and then the variable name, this kind of brings it into the world. It allocates the space for it, and the variable just starts existing. You could say this is like the birth of the variable, birth of an instance. And so there's a special type of thing that happens when this variable is created, and it's a special type of function that's called a constructor. Is that so? Whenever this is created, it actually goes and calls a function called a constructor. And what a constructor is really, it's just a function, but it's a special type of function that dictates how that item is going to be created. And so it allows you to set some things up if you wanted to set some things up whenever a variable is created. And the way we do that, the way we write a constructor, is we just write it using the name of the variable. Here, let's go back to the code really quick. And so what I think is a good idea here is we said we wanted to set the skew, the quantity, the name, and the price. And I think a good way to do this is via the constructor rather than doing all 4 sets, right? I could have called set name, set price, set quantity, all that stuff. What I'm going to do instead is I'm just going to comment out all of these sets, and let's do it via a constructor instead. And so this is the way I normally program these. I normally make a public constructor, and I'm going to make a constructor that just takes all 4 of these things and sets them. So the way we do this is we just give the name of the class, in this case item, and that is how you specify that the function you want to write is a constructor. So here this will be a constructor. I'll even put some comments here that says constructors. We're going to write 2. And I'm going to make it take an integer for the skew, and an integer for the quantity. Let's actually name it. It's going to be weird. I'm just going to put underscores in front of these for the time being. I'm going to fix it later. And there's a reason I'm doing that. String name and whatever the last thing was, float price. Right, then we can just set all 4 of these things at the same time. So I'll set the skew is equal to skew, and this is the reason I put the underscores for the time being, is notice that if I didn't, they would both have the same name, the members and the parameters to this function, and then there's some ambiguity on what I mean. And there's a way around that that doesn't involve naming it weirdly, but we'll get to that. Oh, other way around. Okay. Right. And so this constructor allows us to basically just set all of the things here. Is this similar to how a init would work for Python? And yes, you're exactly right. Init is actually the keyword for a constructor in Python instead of using the name of the variable. Python's kind of weird about its syntax sometimes. They do it that way. Pretty much every language does it this way, but except for Python. But yeah, that is exactly the same. You're right. Any other questions on this so far? So all this does is it's going to allow us to set all 4 of these things whenever we create an object, that is. Now it's probably going to give me an error here at the variable declaration for the array. But really quick, we'll address that in a second. Let's just do this differently now. So what I can do is I can say items sub count equals, and the way we call a constructor, there's two different ways. It's either called when you create the actual object. So one way I could do this is I could create a variable called temp. And in fact, I could put this in the scope here. I could create a variable called temp and then feed it all the values. So I could say whatever order it was, name, SKU, all the way around, SKU, name, I definitely don't have that right, SKU, quantity, name, price. And now what this will do is whenever it reads this variable declaration, it's just going to jump over to the constructor when it's actually created. So it really is just a function call. It works exactly like a function call you're used to, where it just jumps over to the code and does all that stuff. It's just a special type of function call that's only when a variable is created. So this would go jump over to this code and pass all these values, and then it would set all of them. That's totally fine. Another way that we could do this is we could actually just write almost exactly the same thing. So another way to do this is with the name of the class and then followed by the argument list. And so here, if I just put item and the SKU, quantity, name, price, what it's going to do is it's going to go create an item, and it's going to create an item that uses the constructor with the SKU first, and then the quantity, and then the name and the price. So this will go and create that and fill in the thing. I was getting an error earlier, and I mentioned that if you now try to create a value, it's going to get a little bit confused, because what I have here, right, is a variable declaration, specifically of an array. But the constructor that I've written that tells it how to make an item is dependent on those four things. It requires a SKU and a quantity and all that stuff, right? I only have one constructor currently, and that constructor needs all four things to initialize it. So it needs to have all these values just to be able to set the thing up. And if I don't give it to it, then the compiler is a little bit confused, because it's like, well, how do I make this now? So if you provide no constructors, the compiler will just make one for you, but as soon as you write one constructor, it knows, or like has an idea of what you want for it, and so it doesn't fill it in for you. And because of that, if we try to call it with no parameters, and in other words, just write a normal variable declaration, like here with this array, or if I just wrote item temp like this, then it has no idea how to do it, because this is just constructing an object with no parameters. Right? It's just kind of implicit. It's just, I wrote a declaration, please make this thing for me, and it's like, I don't know how to anymore. And so the way we do that is also with a constructor, and it's just a constructor with no parameters whatsoever. And so this here will fix the error in main. It now knows, okay, well, if I don't get any parameters or arguments to my variable declaration, well, I need to go and just use this one that doesn't take any parameters. And what this is called, it has a special name because it's very common to make these. It's called the default constructor. And so this is the one that's called by default if you don't provide any sort of arguments. If you want that to be the case, like no arguments, then you should write a default constructor. I think it's a good idea to write it 90% of the time. And we could just leave this blank, it's probably fine. Or we could, do something if you wanted in default scenario for this to always do the same thing, like, set the SKU equal to -1 and set the name equal to unknown and all that stuff. You could totally do that. And so what it would do is just set all of those values by default to whatever you want. Again, this is just a function, so it will go and do that stuff. What I'm going to do is just leave it blank. I think that's okay for what we're doing. And that should fix most of the errors that we have. Everybody okay on constructors so far? Or any questions? Okay. Doesn't look like it. Right. So we're going to need to write some extra stuff here too. The only extra error it's giving me is from the fact that I moved the print to the header file. I could leave those out and it would be fine, but what we'll do is let's also go over how we can implement functions outside of a class. I am, for the sake of organization, going to take these and I'm going to cut them and I'm just going to move them over. In C++, it's usually considered a good practice to not do what I'm going to do, but I'm going to do it anyways because I think it's nicer to read. I think 90% of the time this does work. There's some strange things with compiler, so this isn't what you're supposed to do, but I'm going to do it anyways. Which is just throw it in the same file. You're usually supposed to put it in a .cpp. But now main is like really clean, right? We just have like the bare minimum, which is great. Now it is still giving me an error. And the reason is because this belongs to this specific class, I need to write it in such a way that it knows it's from that class. So as it stands, when I write these, because they're inside the body of the class, right? Class, and then I have the curly braces. Anything that's inside those curly braces belongs to a specific object of an item. So like we said earlier, right? It's a recipe or a blueprint, and so when we say that, it also means that the blueprint comes along with a function called print item and sort items that belong to any specific item. But when I write it down here, it just thinks it's a global function that I'm trying to write because I've just written in a global scope. It's just not contained inside of anything, and so it doesn't really know that I mean the class item is the one that the print item belongs to. And part of the reason that is because I could totally write other classes that also have a function called print, especially if I just named it print, right, is a totally plausible name for a function to write. I could write 20 classes that all have the name print, and so it might get a little bit confused as to which print you mean. Do you mean it for like the item class, or do you mean it for like a person class that you've written, or what are you talking about? So we need to tell it where it's coming from, and the way you do that is by giving the class name and then these two colons. And it's telling me that it's incompatible. I may have made a mistake here. It's probably the cons. No, I guess not. In any case, what I'm going to actually do now is I'm going to delete the item from that one, and then this one we might actually want to leave still. If we have time, I'll tie that to this. I'm actually just going to put this down here, or whoops, at the top. I'm going to leave the sorting separate from the item class, just because it works on an array rather than a single item. Although normally I would still write it in there, but it requires something special, so we're just going to do it this way. That should fix it now. Oh, it doesn't let me do that because the quantity is private, right? We set it to be private, so what I need to do is call get quantity. This is actually good for the sake of the example too, because notice that now the way I wrote it, right, is just with that getter, the accessor, that accesses the quantity, and then the only place that main is ever allowed to set anything is in the constructor, right here. And so the reason I do this a lot is because it locks you into setting the variables only when you create the object, because that's what a constructor does. And then whenever you want to get it to actually be able to use it, you just use the get because it's public. And so it stops you from ever touching any of the variables after you first create the object, which is kind of what you want, right? Whenever you create one of these, you just want to create it and then never worry about overwriting anything, because you might accidentally introduce a bug into your code if you accidentally set it equal. This stops you from doing that. It's actually very helpful for programming. Right, so this now should get the quantity. This replaces what we had before, and then the only other error is with this item.printitem. And so the way we can call that print item, remember we moved it over to the item class, is we can do it like this. So we'll call it a dot operator is how you access anything. So this now is able to grab print item from each individual item. So it's going to go to item 1 and then call it and tell it to print itself, and then item 2 and call it to print itself and all that stuff. And now because it's actually tied to a class, we don't need an argument that is an item. I don't know why this is still giving me an error. It's incompatible. I wonder if it's because I didn't put namespace standard. Yeah, that would be it. Right. I don't need to give it an item anymore because if I tie a function to a specific class or an object, then it knows that the object I'm talking about is the one that's calling the function. I'm going to draw a diagram for this in a second. So now I don't need to put like this item dot. Again, it knows whenever I'm talking about the SKU, the name, the price, and the quantity, it knows now that I'm talking about the one that's in the item class, and so it'll just go and use ones instead. Right, so I think that about does it. So this should, I'm not going to run it right now, but this should do basically all the same stuff that the previous one did, but we've organized it a little bit better. Right, so I was going to do something with this, right? In fact, I could probably just add on to the picture we had earlier. And so now on top of all this stuff that we had, each item has an has a name, a price, a quantity, SKU that also comes packaged with some functions as well. And so I think it'll help a little bit if we do this with a diagram here. Is these are kind of like self-contained, right? These bubbles can only see inside of themselves and they can't see anything else, right? So if I'm operating within I or any function in I can only see the things that are inside of I can't just go reach over and look at the stuff in J, right? And likewise, if I go and do something like I'll print item, then this has its own version of print item. It doesn't actually copy and paste the code, but in terms of what it's able to do, each of these have their own specific version of it. Right, so when I call print item on I, it will print all the stuff that I has, and when I print all the stuff J, then it will print all the stuff that J has. And so one way to think about this is whenever you're inside of one of these bubbles, it can only see things that are also inside the same bubble, unless we have like a parent situation, which we'll get into. But so when I call print item here using I, so if I did I dot print item, and I access the SKU variable, do something with it, so like let's just say C out it, then it knows I'm talking about this one. That's because this is the variable I, and if you're in I, it can only see other things that are inside this bubble. So it can't see the SKU of J, for instance, because J is completely different. And so we have this notion here of objects and being able to operate on themselves or kind of do like self-contained things. Okay. So if we go back to the code, this print item will now see the SKU, the name, the price, the quantity of whatever it is that we're calling the print item on. So if I ran this again really quick, which let's just do that in Visual Studio. I'm going to go here. Let's just set this, that way we can run it with the debugger and see stuff. I'm just going to set the command line arguments here. And now if I run it, we should see that it outputs the same stuff that the other one did last class. I just got to give it a second to run, which should see like an output file here in a second. In the meantime, any questions while we're waiting for this to run? I finished. There we go. So it says the same thing that we said last time, read 4 items, it generates an output file, and then we see, yeah, it's formatted basically the same way. This is messed up. I might have something wrong with the, something's wrong. Question is what? Oh, oh, this would be the issue. I'm setting the values before the count goes up. So item 0 was just random garbage. You actually notice if you ever get just random garbage, it probably means you forgot to set something. We'll get into why that is in like a week or so, but just for debugging purposes, if you ever see that, it's probably that you either set something in the wrong order or it's not set when you did the print. So here we see that, we can reload it, and yeah, this is what we had last time, right? So sorted in the correct order. Cool. And so this is just same code, but written a little bit nicer, easier to read. Now, what was the other thing they said we were going to do here? We covered constructors. I know I said that I was going to do something a moment ago. Now I'm forgetting. I know we can move the sort into here, I guess. There's something I wanted to do in particular, though. Well, if I remember, I guess we'll go back to it. Yeah, so this should be really just the same code. Okay. So just a few loose ends that I wanted to talk about. Maybe let's talk about moving. Let's move the count over. Let's go ahead and write it in a way that we move the count over. And while we're at it, let's move the sort over for an example. So I said earlier, you know, the way I would typically write it is I would put the sort tied to the item class as well, because it makes sense to kind of group it in there. If it's a function that pertains to items, then it makes sense to group it with items. And so I can do that. But the problem is that sort items is a thing that sorts it like an array. But all of these functions only operate on a single instance, right? From what we were talking about, they can only see inside their own bubble. And so if I tried to call sort just in the normal way that we've been doing so far with these functions, it's not really going to know how to sort the other things in the array because it doesn't have access to them. It can only see inside of its own bubble. So whenever we want to be able to still group it in with the class, but be able to have it shared across all instances, then we can do that with what's called a static variable or a static function. And so that's what I'm going to do here. We're going to use the count for a static variable, and we're going to use sort as a static function. So I'm going to go up here. I'm going to add in the prototype. I'm going to take this. So we'll take sort items, and we're going to throw it right below here. So these are our function prototypes now, and they're grouped in with the items. And I do actually still need an array because, again, we can't see like everything. And so in this case, I actually don't want to get rid of this argument. But what I am going to do is I'm going to call it a static void. So if you want something to be static, just put it before everything else. Specifically the data type that it returns. So this one's void returning. I just got to put static in front of it. And what this does is it makes it not tied to an instance, but just kind of free floating on its own. So let's go back to that picture that I drew earlier. Whenever we create something that's static, it kind of like goes outside of the bubble, is one way to think about it. And so when I do that, I kind of have these static, lagged for a second there, these static item things. And they're only able to be seen by other items unless you make them public. In this case, I'm going to make one public, the function public, and I'm going to make the variable private. And these instances will all be able to look at static things. So static things are ones that are not tied to instances. They only exist one time. Global variables, which we've been used to so far, or constants, are examples of things that are static. They don't ever change. In the case of constants, static variables can change, but they're not like tied to any specific object, right? So if I wanted, for instance, the count that we were talking about earlier that counts the number of items that there were, then the count is separate from any sort of item, right? The I doesn't need to know about the count. J doesn't need to know about the count. They're not like tied to those things. They're just free floating. So count is a really common example of static things. And the other thing I'm going to do here is I'm going to make the sort items function we wrote static. And this way, everything will have access to this sort items static variables, and we'll be able to use it anywhere we want. And actually, if you make it public, then really it's no different than writing a global variable or a global function, which I'm going to do here. I'm going to make this public. The main difference being that it's still more organized. I'm putting it in like the same class, so it's just easier to read. The count, though, we'll see, I'm going to tie to the item class specifically. So we'll go back over. Now this static void means that anybody is now able to see this, but it's just tied to the item class. So I'm going to take the definition that we wrote of sort items, which is right here, and I'm just going to move this over. And then I'm going to put it in the same file. Again, this is just nice for readability, but it's really no different than the code we had previously because of the fact that it's static. So I put static void, this is print item, this one. So static void, and then I need to put the item colon in front of it so it knows it's from the item class. Actually, I don't think you have to put static if it's outside of the class. C++ is again really strange about how it does some of these things. It's one of the first languages to start introducing this stuff. It, in my opinion, doesn't have it like quite perfected. But yeah, you only need to put static in the class itself. So I'm just going to put it there. But this will still be static though. And now, what this does is it's basically just the same thing. It's if we wrote the function in a global scope and just wrote it right next to main, but now it's just tied to the item class. And so we see here it says, well, it doesn't know what it is anymore, and that's because it's not global. And the way you can fix that, there's two different ways you can fix it in C++. The way I recommend doing it, because it's the way that's common in every other language, is to call it statically, because it's static. And statically, from what we show in that diagram, really just means not tied to any specific instance of or object or anything. So didn't belong to I or J in that example. So we're just going to say I want to call the item type function called sort items, and I want it to operate on the things that it operates on, an array and a count. Right. So that's pretty good. That seems to work fine. And now it's just a little more organized in terms of our code. The other way you can call this is with an item itself. So I could actually go into the items array, just arbitrarily pick the first one, and then do sort items. And you'll notice it won't give me an error here. Java and C# and some other languages will tell you that you're not allowed to do this. The compiler will get angry, but C++ is totally okay with it. And so you can write it this way. I don't recommend it because I think it kind of breaks why you would want to do this in the first place. But you could just say, item sub0 dot sort items, or in the example that we did here, I could say like I dot sort items, and technically I has access to everything that's static, right? So that's plausible for it to do, but I would argue that's not. It makes a little bit less sense. The reason being is, if I'm saying sort these items, why am I arbitrarily using the first item to sort it? Like I could just pick item 7 and arbitrarily use that one to sort to, and it would totally work, even if it doesn't exist. So I think it's weird to use an instance to call static functions, but you totally can do that. Anyways, right, this is just a way to group it. It's almost the same as writing it globally. And so now this should, if I ran it again, it should just go here and sort everything. The other thing we wanted to make static was the count, and I did remember what it is that I wanted to talk about, so we'll get to that in a second. So the count is another thing that we know specifically has to do with items. So again, I would just tie it there, again, for the sake of readability. I think that's nice. So I'm going to move that here. And what I'm going to do is I'm going to make this one private. So I'm going to put this here. I can't set it equal to 0 anymore. C++ specifically doesn't let you do that. And I'm going to set this equal to a static int count. Now I do have to set it outside of the thing. So static initialization is really weird in C++. And that's a little bit of a fancy term, but all I mean by that is setting static variables for the first time, because that's what initialization means, right? You can't do it in the body of the class for whatever reason. I don't know why. I'm not sure why the compiler doesn't allow that. Maybe there's actually a reason. You actually have to do it outside. So I would typically just do that down here, I guess. Again, the way that we say we want something from a class is we give the name of the class and then the scope resolution operator with the 2 colons. I would say count equals 0, and I think I actually have to put the data type as well here, and it will set it. Oh, and I see a question. So what's the difference between using static initialization in the class versus using something like a namespace? In C++, there shouldn't be a difference. So that's a good question. C++, there shouldn't be a difference. The compiler might have some sort of technical thing, especially if it's in a header versus a CPP file, because I know it treats those differently for some reason. But there's actually no difference in terms of usage between those things. And you'll actually find that other languages that kind of focused on what they wanted to do with like object-oriented programming, like Java and C#, just totally get rid of the ability to make variables in a namespace anyways, because there was no difference, so they kind of just threw it in with the static initialization, if that makes sense. And if you have time, would you mind going over classes again and the difference between private and public? I can definitely do that. And will we need to use constructors in this way on the assignment? Not on the first one, but on probably the second one you will. Anytime we use a class and you need to instantiate a class, which we'll be doing a lot, then you'll want to write a constructor. Anytime you think you need to do something when you create a variable, because that's what a constructor is, then you'll want to use it. And we'll go back to private and public here in a second as well, because I did see a question about that. I think we tied up all the loose ends. I made a static int count, which just like the picture here, just means that the count doesn't belong to any specific item. It's just going to be like a free floating count, so it's like separate from everything. And I initialized it to 0. Let's finish that up really quick, and then we'll talk about private and public, and then I'll talk about one other thing. Yeah, so you see here, it says it doesn't know the count anymore. So I could either do it this way, I could just do that. Actually, it's not going to let me, it's private. So I'm going to do this the same way that we were doing all the other things. I'm going to use a getter, or a mutator, or sorry, an accessor, to grab the count. And one thing to note is that static variables can only be used in a static, well, actually no, other way around. If you have a static function, you can't use instance variables, so things that are non-static. I'll do an example of that at the end. Let me actually make a note of that. So instance variables in a static scope, or we'll talk about that in a little bit. So yeah, we'll just say static get count. Static in the count is an integer. Static ints get count, and then this will just return the count. And what I was saying, which may have sounded a little confusing, I know I'm probably getting a little bit ahead of myself here, was that we can't use like instance versions. So all I mean by that is I can't use like skew or quantity if the function is static. We'll see why that is. I'll draw it out a little bit. But I'm just going to limit this behind a get count, and then I'm going to make this get count in order to grab it. And because it's part of the item class now, I got to do this. But I can't do ++ anymore. And the reason is because it's private. I've only allowed myself to be able to get the count. I haven't allowed myself any sort of way to set the count. And so the way I would typically do this, rather than write a set count and make it +=1 or whatever, is I would actually move this into the constructor. So here, I'm gonna go ahead and do this. I'm just gonna put count plus plus. And now what this does, with the way I've set it up, is it increments the count of item variables whenever one is created. I should probably comment this a little bit more. Initialize all our values. So consider that the constructor is called when it's created. If I set count plus plus equal to that, then count's only going to ever get incremented whenever I create a new object using this constructor, which means I've locked the count going up only to happen when I create an object, which is really nice and I think super convenient. So this is kind of the way I usually do this, if it makes sense. So I see another question, and it says private, but can a global variable of count still be accessed by private classes? I guess it kind of depends on what you mean. If you mean like with private inheritance, then no, which we haven't gotten to inheritance yet. But if you mean can a global variable that is, or do you mean like just a global variable? If I was to write, sorry, I guess I think I understand what you mean now. If I was to write this like const int, let's just say count 2 because I already have another one, and just write it kind of free floating as a global variable, are you asking would I be able to access that in the class, even though the class is private? Yeah, yes, you would be able to. Actually, something to consider is that any global variable is just public because it doesn't belong to any class or struct. So if you just write any global variable or global function how you would have in CS 135, then it's going to be accessible by anyone. And anywhere in the program for that matter, as long as it has access via like all the includes and stuff. Yeah, it's a fair question. Good point. So yeah, I could use count 2 here anywhere. In fact, I could do this here. Count 2 plus plus. And there. Expression, oh, it's because I said to be a const, but yeah, it does see it, at least. In fact, that is another approach to this. I could just not make it static and do that, and it would be fine. One thing to actually note about global anything is I said they're public, but they're also always static as well, because they don't, again, belong to a class, and that's where like instances come from. They're all static, they're all public. And so anything that I say about static variables in the future here also applies to globals as well because of that. Yeah, so good questions. I think we're okay with all this stuff. We now have the count plus plus here, so that fixes the issue with it being here. I think I just need to get the get count. And then we'll go over public and private really quick. So red, item, get count. And then actually because of this, I don't even need to pass the count into this function anymore. And really nice for organization. I can remove that from the sort items because now every item function has access to it. So, you know, it doesn't really need to have that anymore, right? So it still is able to see the count here, which is great. Yeah, so you see it doesn't give me an error when I try to access the count because this is a function that belongs to the item class, so I can just see that static variable. And anytime I write a function, it has access to private variables. So it is handy now. So now main essentially can't do anything to the count. It is not allowed to modify it, but the item class just handles all of it. So it's kind of like a black box approach if you've heard of that before. We don't need to know how the item class works when we're using it from main. We can just have it do what it needs to do and then just take peeks into the black box to grab only the things we need, but not any more than that. And so now I don't need to know how it does the count, how it increments it, or how it modifies it in any way. I can just grab it whenever I need to grab it. And that's about it. Which is good. It allows you to kind of simplify your thinking outside of writing the class. So now if I had written all this stuff earlier before this lecture, then we would come back here and writing main would be like way easier and I wouldn't have to do it. I know it may seem complicated now, especially if it's your first time seeing this, but if you kind of break the problem up, it ends up being nice. Anyways, I think that covers all that stuff for static variables. So I got a question on reviewing what private and public mean. So private, let's do another thing here. Things that are private are only accessible to that class, and things that are public are accessible to everybody. So I'm going to go ahead and do another class example here. I'm just going to call it person, and I'm going to give it two fields. The first one is going to be a public integer called name, let's just say, and it's going to have a private member, and that's, oh well, that wouldn't make sense to me. Let's say string name, and then an integer age. Okay. And for the sake of the example, let's also throw in a function with some modifier. Doesn't matter which one it is. I'm just gonna say do the thing, make it void, I guess, and then we'll write it down here. So let's say I have this, and then I go off into my other file, and I have first things first. I have the void person do things. So I'm going to write something that belongs to the class. In other words, this is code that is accessible, or that has access to anything that the class has access to, specifically this class here, the person class. So any constructor, any function that belongs to a class is going to have access to things that belong to this. And then I'm going to say, if I wrote ... some more code, and then there was main eventually, and I came to main. So let's say I write two lines, the same two lines in main and in this do thing class. I'm going to output the name of the person, and I'm going to output the age of the person, and then I'm going to go here and I'm going to output the name. So let's say I would have to create an object. So let's say I do, actually let's put that back. Person P, and then let's say I've written a constructor and it works and sets all these things somehow, and then I try to see out p.name, and then I try to see out p.age. So let's go through one by one and try to figure out as a class which ones of these work and which ones of these don't. So first things first, does this line of code, the see out name in the do thing function, which belongs to the person class, is that going to work? Is that going to see out the name? Or is it going to give me a compiler error? So I see a lot of yeses, right? And you guys are all right. This is good. That one's fine. Let's take a look at the same equivalent one in main. Would main be able to print the name of a person? Right? I think I'm seeing some more yeses. I'm not sure if those are the same as the yeses from the other one, but yes, we'd also be able to see the name of the person in main. Remember, public means accessible everywhere. So anything that's public, in this case the name is public for any personal object, then it's accessible both inside the class, in any other classes that we write. So I could write a class called item again, and it could totally see any sort of person name, and it would be able to access it because it's public, and any other code that I write, be able to see it. So public just means that anybody anywhere is allowed to modify this thing, or at least access it in some way. Now, the age, though, that's private. Let's take a look at that. I have one example where we print the age in the do thing function, which again belongs to the person class. Would I be able to print the age here? It's private, right? So would I be able to print it? Okay, yeah, so I see it. I see a yes, and you would be right. Perfect. So yes, we can do that. What about in main? Could I print the age here in main? No. Okay, I've seen a lot of those. Yeah, and you all are right. So private, right, means only only the class and only code that belongs to the class is able to see that variable. So I'm allowed to print the age here because this code belongs to the person class. It's the function do thing, which is a person function. So any kind of private variable or public variable is accessible to code that belongs to that class. Main, on the other hand, is able to see the public thing because that's what public means. It's able to access anything, but it's not able to see the age because the age is restricted, which sounds funny out of context, but yeah. So private variables are only accessible in code that belongs to the class, and there's one extra modifier called protected that we'll get into when we actually get into applicable cases for it, which means it's accessible to the class and anything that builds off of that class. And so that's kind of the distinction. So I think there were two more things. We'll try to finish up. I know we've only got a few more minutes. So the first thing I think, oh yeah, I mentioned instances of a variable in a static scope. I might actually just talk about that next time because I feel like that's going to take a while. Last thing we'll end on then is just how we deal with ambiguity in naming. And I mentioned this like way back when we started the lecture, but I was naming these things kind of strangely, right? I said item int and then I put an underscore skew, and the reason I said I was doing that, right, in this constructor was so that I wasn't naming things the same as like these members. So just for a frame of reference, so I guess have something to build off of. You might remember from CS 135, if I was just in global scope, if I wrote integer x, I don't know, equals 0 or something like that, and then I wrote a function called, foo or whatever, then I made something called int x equals 4, and then I see out x. What gets printed here? Okay, cool. I think I see something in chat. So somebody said 4, and you right. So 4 is going to get printed here. What if this line didn't exist? Would it still print 4? Or would it give a compiler error? Or would it print 0? Yeah, you're right. It would print 0, right? And so the way that we said scope works is that whenever we use a variable, it looks for like the most recent scope that exists in. So this one would look, inside the function that exists in. So it would say, okay, we'll go here and look for foo, and then if we find it, then great. In the first case we found it was 4, and if this didn't exist, then it would go and look in the most enclosing scope, like the last enclosing scope it was in, and it would try to look at that one. So it says, okay, well, there's a 0 in this scope that I'm in. Right? But if I declare this in main or something like that, if I tied this to main, then this no longer compiles, right? Because it can't access it. So it has to be in some sort of enclosing scope. And so the reason that we have that in the code we wrote earlier is because if I tried to write this name as just skew, then it would get confused between this one, these parameters called skew, quantity, name, and price, and the instance ones that actually belong to the class. And if I actually did it this way, it wouldn't give me an error. It's giving me an error because there's no underscore anymore, but it's now going to do the same thing where it overwrites it. So remember, we said that the last one, it would like print the 4 because that one belongs to the class, or sorry, to the function, and anyone that's in a scope that's enclosing it is going to get overshadowed. It's going to get ignored. So when I do this and I name things the same, it's going to say, Well, you want the parameter skew, right? So all of this here, these lines of code are just going to take these parameters and set them equal to themselves, so it effectively does nothing. So part of why you should name things well is that it'll overshadow these and you won't be able to see them anymore. So there's two approaches to this. Either you just name them better, like I did earlier, and the other way, so this last thing we'll do, is you can use the word this, and we'll talk about what this means in more detail, followed by an arrow, and it will understand that you're talking about this object. When I use this, it now knows that it's talking about this thing here. So really quick, last thing we'll do for class, let's just run this and verify that it works, and I have a compiler error, so I guess it doesn't. I have some sort of semicolon missing or something. File. It's probably this. If this doesn't fix it, I guess we're gonna end class and I'll fix it before I upload it to Canvas. I think it's running. Okay, cool. Yeah, and then again, let's just verify it works, and we see that I'm doing some sort of error. Oh well, we'll worry about it next class, I suppose. But the point I want to leave you with is just that if you ever are getting something where it's ambiguous between parameter or some sort of redefinition of a variable and the instance, like the things that belong to a class, then using this keyword would fix that. Right, so I guess is that a pointer? Yeah, this is a pointer. Yeah, you're exactly right. Cool. All right, I guess sorry to keep you guys a little bit over, but I will see you all on Tuesday. Make sure to check up on assignment 1. I updated it. It's due next Thursday. I'll stay after a little bit if anybody has questions, and I will see you guys next week.